That is not the right slide. Can we go to the beginning of my deck, please? Hi, welcome. Further back. There we go. All right, please take your seats. We're going to get started here. I do need a countdown. I need a 5-minute countdown. Welcome to DevOps Days Minneapolis 2019. So there are about 850 of you here for our 6th year. I'm amazed at how much this community has come together to do this. It's fantastic. And we're learning and sharing about building bridges between teams and orgs and industries. And it's amazing to me the representation we have from across our industry here. Very exciting. I'm Bridget Krumhout, and our local organizer team is happy to help you with anything you have questions about. We're really happy you're here. Talk to anyone with a staff badge, or the info desk will be staffed all day today and half of the day tomorrow. And like last year, we have live captioning. So if you feel that that would be useful to you, please come on up, sit near the front. By the way, the bin packing algorithm that is conference seating means that there are lots of individual seats in the middle that are not filled. If you're sitting by an edge and you don't feel the need to be that close to the edge, moving in towards the middle makes it easier for people to not have to climb over you as they sit down. We have about the right number of seats. We don't have a lot of seats to have a seat for your bag. So, let's see. And yeah, we also have some space, I believe we have some space for wheelchairs near the front, if you would like that as well. And if you're on call, I'm sorry, and also we have power at tables near the back so that you can actually sit and clickety-clack and work without feeling like you're disrupting anything. Okay, let's see. So this, by the way, is the 10th year of DevOps Days. It's the 6th year in Minneapolis, but it's the 10th year internationally, which is really exciting. It grew out of a conversation at an Agile conference in 2008 between Patrick Dubois and Andrew Clay Schaefer. Patrick went home to Ghent, ran the first DevOps Days. There was one in 2009. There are more now, obviously. And yeah, I think we have 73 confirmed events for 2019, and 2020 is coming online. So if you're thinking to yourself, I flew or drove a long way to get here, you should talk to any of our staff about maybe organizing a DevOps Days closer to you. We have one in Chicago later in the month, and we still have wonderful people who organize one in Madison. So it's like, why not have one closer to home? Okay, we keep the ticket prices for these not-for-profit community events low with the help of our sponsors. So we'll hear a little from them on this stage in the next couple days, but I encourage you to go chat with them in the sponsor hall next door. That's where your all-day coffee and snack breaks can be found. And better yet, they have giveaways, raffles, might even have a new job for you. Talk to them when your coworkers aren't looking. But any of the ones that are the local employers, they're there because they want to hire you. And they might even have solutions for, for your technical problems you have too. We'd also like to recognize our community sponsors because DevOps Days is this once-a-year event, and yet there are meetups and hackathons in our local community all year round. So that's what keeps the local community thriving. This event is a little different from some. If you would not mind raising your hand if this is your first DevOps Days. And I think we at least 80% of the room. As per usual, this is their first DevOps Days. We have a lot of people filing in as well, so one more raise a hand if you have an empty seat next to you. Yeah, so empty seat next to you, just raise their hands for the people filing in. But we have this concept of open space attendee-suggested breakout discussions and hands-on workshops in the afternoon. So after your thoughts are provoked by talks this morning, you'll be able to suggest your own topics and interact with others. We also have a job board out in the foyer, so use that to convince people to join your orgs. And the conversation doesn't stop, obviously, here on the 3rd floor of the Hilton, so please go ahead and tweet with hashtag DevOps Days. Invite yourself to the DevOps MSP Slack team. Come to the monthly meetups. Keep those connections going. Quick word on the code of conduct. While we're here together, it's important to remember we have a code of conduct. The whole thing is on the website. You should read it. We will enforce it. And the TLDR is not everyone is exactly. And that is okay. In fact, it's good, but we don't want to judge and make assumptions about each other. People who work in different industries, people who have a different background from us, whether they're different in a visible way or in their lived experience, we should treat everyone with respect because we're here to share and learn, and everyone has something to offer, something to learn. So what are we going to learn? Well, we have devopsdays.org. You can click Minneapolis. It's the very first one. This all seemed very far away when it was much further down on the page. And this is the very first one. The schedule is on there. This morning we have 4 great speakers before lunch. Then lunch we'll have ingredients posted for anyone who has dietary questions. And we do have a quiet room. If you choose to eat in there, please respect the people who want quiet. And after lunch, on this stage, we'll start selecting discussion topics, and across the hall in the Duluth room, we'll have an interactive workshop you're going to use your laptop for. And then after the break, we'll have more breakout discussions, another workshop. At 5 p.m., you'll want to be in the sponsor hall for a happy hour, and it's sponsored by Google and New Relic. And then at 6 p.m., back on the stage, we have 5-minute Ignite talks and Killer Robot Video Bingo. So if you were still hoping to use the on-site childcare tonight that runs from 4:30 to 6 p.m., so you could do the evening event, stop by the info desk. We do have a few spots left. Okay, so let's hear from our first sponsor. Remember, please give the sponsors your attention because they are paying for this.
Hello, DevOps Days, Minneapolis. I'm happy to bring to the stage Mark from SignalFX. He's our first platinum sponsor. Thank you.
Is my mic working? There it goes. Hello, everyone. My name's Mark Fink. I'm with SignalFX, and we are an observability solution that is built from the ground up for the challenges of ephemerality in the cloud with microservice and container-based architectures and the scale that you run into with that. We really give a whole new meaning to real time that is, I think, you can't appreciate. You have to see it to believe it. So please come by our booth so we can show it to you. We have, when we say real time, like I say, we really mean it. We're giving updates every second, and it's our streaming architecture that enables that. The solution was built. Our founders originally worked at Facebook years ago, and they built their monitoring solution there, and they took all the lessons learned that they from that experience and put it into this product, and we've been selling it now for about 5 years. We support a wide variety of verticals. We have a lot of customers now across a lot of verticals. So it really is a solution that plays well across the spectrum. As we talk to accounts, customers, we find that they're at different places along the path towards cloud native. Everybody's kind of moving towards the right there of pure cloud native, but we find people at different places along the way, and as they move along, the thing you find is that they're moving more towards microservice architectures that are broken up into a lot more endpoints. And the more endpoints you get an explosion of metadata, and then also you have the problem of churn where containers are coming and going. We have one customer that turns containers, 30,000 containers a day, and that creates huge challenges from an observability platform perspective. Dealing with the churn and then just dealing with the sheer volume of data coming in. It has to be massively scalable. And it makes it challenging for traditional observability solutions because they are based on a batch architecture where all the data has to come in and write to a time series database before you can do anything with it, before you can put it up on your dashboard, before you can do any kind of alerting on it. And there's just an inherent delay to that, to writing to a database. You're usually at least a few minutes behind. And a lot can happen in a container environment in a few minutes. And so we've solved that problem with just a whole different architecture where the data comes in and it comes through a bus that you see here kind of in the middle. And it comes through and the database is off to the side here just as a subscriber off that bus. So the data is able to go straight through to your dashboard on your screen on the far right there and to our alerting engine. All that happens within seconds of the data coming into our system. And the only time you're actually hitting the database is when you're actually doing historical analysis. And the data comes in, with the default granularity of 10 seconds, we can go down to a second. So that data is just plotting on your screen second by second, and you can see exactly what's happening in your environment. Whenever a container changes, whenever anything happens, it's extremely real time. just some general points. All of our instrumentation is open source. It's based on things like CollectD, StatsD, Prometheus. So we're not locking you into any proprietary instrumentation. We also work with open tracing libraries like Jaeger and Zipkin. So it's all open source. It's, I've stressed the fact of how real time it is. The GUI, or the UI on it, is extremely easy to use. We've put a lot of time into really giving you very fast time to value and making it extremely easy to use, so you're not spending a ton of time configuring it and getting it to a point where you can actually use it. And then it's built for enterprise, where you can carve things up into teams and really control who has access to what, so they only see what they need to have access to. So it's built for enterprise. And so just generally, we're looking to help customers improve the customer experience of their cloud apps. Support that very fast-paced DevOps culture. We have API integrations with everything, and reduce your costs overall. Thank you.
Thank you, Mark from SignalFX. Be sure to stop by the sponsor hall and visit all our fabulous sponsors. Thank you.
All right. Thank you so much to our sponsors. So at this point, I want to thank and welcome to our stage Liz Fong-Jones. If you wouldn't mind joining us on stage, Liz. Everyone, give it up for Liz. And I am so excited that Liz is joining us, because she is one of the speakers and technologists for whom I have the utmost regard. And I'm so thrilled that we get to hear about that fun place called production from someone who has a great deal of experience with it. Are we good? Are we ready to go?
I do need my slides to come up
yes.
briefly so I can send them to present mode, because my laptop went to sleep.
Very exciting. But in any case, again, if you're standing, I see people standing in the back, please take the opportunity to come forward. Please raise your hand if you have an empty seat next to you. So the people standing in the back who want to be sitting in the front can come and do so. This is, I know, right? It's like we provision chairs and then people are like, I don't know. We gotta load balance ourselves and have someone in every other chair. All right. So, without further ado, give it up one more time for Liz Fong-Jones.
Hello, everyone. I'm going to give people maybe 15 seconds to get settled. Seems like some people are getting settled. Excellent. So hi, I'm Liz Fong-Jones, and I'm a developer advocate at Honeycomb, which is a company that provides observability to companies. And my illustrations are done by the wonderful Emily with curls. So those are not by me, but they are definitely great illustrations, I happen to think. So today what I want to tell you about is how we can make production simpler, how we can understand our production systems. And if my clicker would work, there we go. Okay, so we live in a world where we have more and more production systems, and they're more and more complicated. We have so many different microservices, we have so many different environments that we're scattered across, and unfortunately, these same techniques that used to work for us don't work anymore. Especially in situations where you're scattered maybe across a data center and a cloud provider. Or maybe you have hundreds of different microservices. Some of us can dream of getting to that point, right? That's not everyone. But at the end of the day, the problem is that we no longer have a clear definition of what up and down mean. Does up mean that all of my servers are up? If 100% of my servers are responding to ping, does that mean that my system is working correctly? What about measuring starting with user complaints? What if I wait for the calls to come into my customer support center and then I say, oh my goodness, my service is 100% down? I don't think that works very well either. So even if you have a great measure of that, how about juggling everything else that we're supposed to do as people who practice DevOps? How do we manage to find the time to do that when everything is constantly on fire? I think that we need to look at the problem starting from the beginning and figure out, why are we here? What are we trying to do? And figure out what strategies will work for our environment today. One thing I know is true. Don't buy DevOps. With much love to our friends in the vendor hall, and including to myself, right? I do work for a vendor. I do have stickers. You can see me afterwards. Don't buy DevOps. Here's what happens if you try to buy DevOps. Well, let's put all of our developers on call. Let's go buy PagerDuty and put every developer on call. That'll solve our problem, right? And let's go and put in some wonderful continuous integration, continuous delivery systems, because shipping more stuff faster, right? Like, let's ship as much crap as quickly as we can, right? That's going to solve our problem. Or what about if we, what's a Kubernetes? Do I need one? I guess I want one, right? It's in the alphabet soup. I want to order it. That's clearly going to go great, isn't it? And let's get some infrastructure as code too, right? Like, let's get some infrastructure as code so we can automate breaking our production as quickly as possible. So what happens when you do that? Well, your engineers get really, really unhappy because they're getting woken up every single night by things that they can't understand, that they can't fix, and the complexity is rising, and they feel like they have no control. And eventually, they shut off their pagers. And that sucks. And even when someone does decide to investigate, that vendor that you brought in to do these wonderful dashboards, well, now you have 100 different dashboards with 10 different graphs on each one. Which one should I look at? I don't know. Well, I guess I'm going to spend the first 20 minutes debugging anything, looking at this wall of dashboards to see which line wiggled at the same time as this other line. So that's not so great either. And then on top of that, people add all these other dashboards that they think are useful that solve their last incident. Well, their last incident is not your last incident. So the net result of that is that your incidents take forever to fix, your users are getting unhappy, and maybe you have one expert on your team. How many of you are that expert? Everyone bugs you for help. Yeah, I know the feeling, right? Like, when you're that expert, then you can't actually get anything done, and you can't ever go on vacation. And even if you have the most beautiful continuous integration, continuous delivery in the world, if all you're doing is testing each individual box rather than how the system relates to itself, then you're going to wind up having the space between your connections, right? The space between your services break. And then stuff doesn't roll out and stay in production because you're constantly rolling it back all the time. So this is a state that we call being operationally overloaded, where you have no time to get projects done because you're getting paged all the time, you're getting interrupted all the time, you can't make any progress. And even when you do have time, there's no plan. You're lost in the woods, you have no map, and you don't know, how am I going to get myself out of this mess? So you and your teammates are going to feel like you're struggling to hold on, like you're just barely hanging on to the system and its complexity by your fingernails. So what did we do wrong? Well, okay, first of all, we bought the alphabet soup, but besides that, what I'd argue that we're missing is that we failed to start with thinking about who operates our systems and optimizing for their reality and optimizing for their happiness. Our tools are not magical. Tools can only help you automate something that you already know how to do. If your processes are not set up in order to facilitate effective debugging and troubleshooting, no tool is going to help you. We really need to invest in having excellent people, culture, and processes in order to effectively run today's production systems. So this is what I call production excellence. We have to make our systems feel that they're friendly to work with and that they're more reliable and more resilient. You can't get there by accident. You have to establish a long-term roadmap and plan and figure out, how am I going to get there? And that involves, yes, sometimes a Trello board, right? Thinking about what actually matters, what am I measuring, how am I going to get there? And you can't just do it with a set of people in this room. I'm sorry, right? Like, you have to reach out to people across a wide range of teams, including both people who operate systems, people who design and write systems. Obviously, some of us are both, right? As well as folks that you might not expect, like your business side, your sales teams, your product managers, your support teams. These are all important stakeholders that if you go off and charge ahead and do your own thing, you're not actually going to bring them along. So bring everyone along. And not just invite them to sit at the table, but actually encourage them to participate. Make sure that we have a safe, blameless culture where everyone's encouraged to ask questions. And in order to do this, I think that there are kind of 4 key things that I'm going to tell you about today of how we achieve production excellence. The first one is we need to know, when are things too broken? Not, are things broken right now, oh my goodness, it's on fire, but instead, are things too broken? Are they trending up? Are they trending down? And when things are too broken, we need to be able to debug our systems with each other together when our systems are too broken. And finally, we need to close that feedback loop. We need to be able to eliminate unnecessary complexity. Every system, of course, has complexity. Some of it's essential. Some of it is related to the business function that we're trying to provide. But a lot of our outages come from places where we've introduced too much complexity or too much technical debt, and we need to kind of have a plan to reduce that. So how do we do this? Well, I'd say our systems are always failing. We need to embrace that. That is the way of DevOps. We need to think about the idea that our lawn's made out of grass. We don't care if every single leaf is green. It's okay if a few are brown, right? Like, that's okay. So we have to focus on what does the system as a whole look like and measure what does too broken mean. So for this, we need the concept of a service level indicator. A service level indicator and its companion, the service level objective, give you common language to talk with your stakeholders, to talk about what is the level of reliability that we're targeting, and how are we measuring it? How are we achieving it? And the way that I like to think about a service level indicator is in terms of events in their context, and events that specifically impact users, right? What is the workflow that someone goes through if they're trying to add an item to their shopping cart and check out, right? Think about, is this event, is this user experience good or bad? And can it be determined not just by a human calling up your support center, but can you proactively detect whether or not an experience is likely to make a user upset? And if you don't know for sure what causes that and what's correlated, maybe ask your friendly neighborhood product manager, or maybe take on kind of the product manager hat yourself and interview some users, talk to them, figure out, do I abandon the page when it takes more than 500 milliseconds to load? So that kind of centers the idea of thresholds, right? Thinking about how do I divide these events into good and bad? One criterion that I might hypothesize, for instance, is maybe on my sample service that if a request was served with HTTP 200 and it took less than 300 milliseconds, that's a good event. But of course, I don't want to track every event coming in, right? You have your health checks, you have your botnet attacks. You probably don't want to count those against the set of events that are user events. So once you have your set of eligible events and good events, then you can see what is your total availability and set a target on it and decide what level of reliability am I trying to achieve and over what window of time. For instance, I might say I'm trying to target having 99.9% of user events be good in the past 30 days, where each event means that it was good if it was served in less than 300 milliseconds without an error. And a good service level objective barely keeps users happy. If a user occasionally encounters an error, that's okay, as long as they can click reload and have it work fine. Now, of course, that may vary, right? The difference between an e-commerce website and an airline is very different, right? You probably don't want your planes falling out of the sky. So we can kind of think about what's the appropriate level of reliability that allows us to move as fast as we need to while keeping our customers happy and safe. And then we can use that for things like alerting. So we can think about, when do I need to wake a human up? When is it important enough to wake up a human, and when can it wait for the next day? So to do that, we need to think about the concept of an error budget, to think about how much an availability am I allowed. So if I'm targeting 99.9%, that means that 0.1% of requests are allowed to fail over a 30-day window. So then I can look at how quickly am I burning through those allowed errors, right? It's like, how quickly am I burning through money in my bank account balance, right? Am I going to run out on Saturday? Am I going to run out 3 months from now? When does my next paycheck come in, right? And then you can take action. And only if you're going to run out of your budget in a matter of hours do you need to wake someone up. Otherwise, you can file a ticket and let someone deal with it during business hours. But the other really powerful thing about service level objectives is letting you make data-driven business decisions. For instance, is it safe for me to do this risky experiment, given that I know I can roll it back within 30 minutes and it'll only affect 1% of users? Well, if I've got plenty of error budget left, if the service has been stable, why not? That error budget is there for us to iterate and use for velocity. But if I'm running low, maybe I need to spend more time re-architecting the system to make it more reliable. So you don't have to get it perfect on the first try, because measuring is the first step to doing anything. If you don't measure, you don't know what you don't know. So measure what you can today, but think about, how am I telling whether or not this aligns with user needs? Maybe users don't actually care that it's less than 300 milliseconds. Maybe they care that it's 500 milliseconds, or maybe they care about something else entirely. So be open to that feedback. So once you only alert on what matters, you're a good way towards achieving production excellence. However, that's only half the picture. And the reason is that it doesn't matter whether or not you get notified of an outage if it takes you forever to fix the outage. So our outages are never identical. They don't work in the same way every single time, or if they do, you're not actually fixing your outages, you're just letting them happen over and over, right? So you can't predict in advance what failure modes are going to happen. You can't predict in advance what questions you're going to need to ask in order to debug a system. So you have to be able to debug new problems in production, not just in your staging environment, in production. Otherwise, you're never going to be able to figure out, hey, the site's down and I can't figure out what's going on. And you have to be able to form and test new hypotheses, right? You have to have people feel like they can ask their systems any question that they want. If you don't empower your humans, if you take their autonomy and power away and say, this magical AI system is solving all of our problems, you're not actually empowering your humans. It turns out that the most powerful DevOps tool is not anything living in the cloud. It's between your few ears. So that means that we have to be able to explore data. We have to be able to ask these new questions and get answers. So our services have to be observable. And to define observability, in my own words, what observability means is that our systems can explain themselves to us and can answer questions that we have without us having to deploy new code. And that we can look at our events in their full context to understand, how do they relate to each other? And how can we tell what distinguishes a bad event from a good event, right? To figure out what went wrong by figuring out what is the difference between these two categories of events. And really, the gold standard of observability is when your systems are automatically mitigating what's going on, so that you don't have to interrogate your systems in real time, but instead, you have enough telemetry in order to understand what happened hours after the fact when you're debugging later, once you've woken up after a solid night of sleep. So SLOs and observability go really well together, because one is about detection and telling you when things are too broken, and the other one is, okay, things are too broken, how do I fix it? But that doesn't alone solve the production excellence problem. You also need to have collaboration between different teams. Heroism of being that one person who's the expert in the system just is not sustainable. You cannot do it day in and day out and rely upon it to create a resilient socio-technical system. We have to think about debugging as a collaborative activity that's done by more than one person on the same team and done between different teams. So many outages today happen because of intersections between different teams' services rather than being localized only in one service. We have to work with each other, and not just between engineering teams, but also thinking about working with support, working with data center ops, thinking about all of these job roles that we have to collaborate across who all benefit from working on production excellence together. Because at the end of the day, all of us are here doing our jobs because we care about our customers. And collaboration is fundamentally an interpersonal thing. Collaboration fundamentally relies upon having people have the trust to give each other feedback, having the trust to raise their hand and say, I don't think that looked right. Like, can we go back and look at that? If you don't wind up having people feel safe to work with each other, then your system's not going to wind up being very reliable in the long term. I know that Charity and I talk a lot about service ownership, but service ownership does not mean selfishness, right? Service ownership doesn't mean that this is my set of Legos and I'm not going to share it, right? What it means is you are accountable for that, but it doesn't necessarily mean that you're not willing to work with other people in service of achieving reliability for that service. So don't ship your org chart. And we really have to think about leaning on our team in order to achieve a high degree of resiliency. When you are trying to achieve sustainable operations, it means that you have to fairly allocate responsibilities across your team. And I say fairly and not equally. That's important. Think about people on your teams who might, for instance, observe Shabbat. Should you put them on call on Friday evenings? No, right? We have to be able to cover for each other. Think about the person on your team who's just had a kid. Think about the manager who has meetings during their day and therefore can't be on call during the day. If we all pitch in and work together and create a fair and equitable on-call schedule, we'll have a much better functioning team. If you cannot sleep, you cannot be creative. So make sure that people, if they've had a rough night of on-call, get enough sleep the next night. And also, make sure that you're documenting things as you go along. Like, leave yourself cookies, not traps, in the words of my friend Tanya Riley. You have to write down the right amount of detail. You don't want to write down things that are going to become out of date, right? But you have to give yourself enough idea of how do I start debugging the system? How do I understand what's going on? How do I mitigate right away? That's honestly the most important part of documentation is, hi, I'm a new SRE on your team, and my pager just went off. How do I mitigate and get things back to normal as quickly as possible? So don't runbook everything. It's just mainly, what are your mitigations? And we really have to fix that problem of being that hero on your team. Find that time to share your knowledge. Find that time to write down the questions that people are repeatedly asking you and the answers so that they don't have to ask you every single time. You have to think about the fact that one day you would like to go on vacation. You have to think about how do you empower your team to onboard new engineers. If you don't do that, then your new engineers are going to be hopelessly lost. And it's not just a matter of pushing information at people. You also have to make sure that you're hearing from them what their questions are and not yelling at them of, how could you possibly not know that, right? Instead, think about, that's such a great question. I'm glad that you asked it. And it sounds like our documentation is not clear enough, right? That clearly shifts the tone of the team depending upon which of those answers people get when they ask questions. So reward that curiosity and also reward people who go above and beyond to do things for the team. Really reward that teamwork. In Honeycomb Slack, and actually on our community Slack, we have a channel called #love, where people say, hey, I'm really grateful to my colleague Dai for helping me with this UI bug, right? Or other things where you're like, yes, thank you. It makes people feel seen. It makes people feel appreciated. And of course, do blameless postmortems. So we have to learn from the past in order to make our future work better. And that requires thinking about how do I make my future work less painful and learning from my previous mistakes. So I said earlier that outages don't exactly repeat, but outages definitely do rhyme. In particular, outages frequently share common characteristics that you can identify by looking at patterns of them over time. Or even better, you can look at and proactively try to analyze your system to figure out what are the risks that you know about. Of course, there are always going to be risks that you don't know about. For instance, maybe I have a bridge, and it's crossing a river, and the deck is falling down. Cars are falling through the deck, and maybe it needs a seismic retrofit as well at some point, and maybe every 100 years there's a freak tsunami. But we don't know about that yet, right? Which things should I prioritize working on? I think it's important to think about how often does the risk happen and how bad is it? And by how often, I mean the time between incidences that you know about. For instance, it might be the case that I operate a continuous integration system, and everyone loves to check in their code on Friday afternoons, right? So my system gets overloaded every Friday afternoon, right? That's a pretty high frequency. It happens every week. But what's the impact, right? Maybe the impact is that our builds take a little bit longer to go out, but they still go out, right? So maybe it's not so bad. So think about how many people are impacted and how severely. Often, you have a lot more control about the impact than you do about the frequency. For instance, I can't necessarily control the fact that everyone wants to check in their code on Friday afternoons. But what I can control is making sure that instead of the system breaking for everyone, maybe we tell 30% of the users, sorry, you can't check that in right now, right? And that lets 60% of the stuff flow through, right? You can reduce the fraction of people affected, or you can reduce the length of time that they're affected for. And by multiplying these two numbers together, you kind of get the total amount of risk. And you can think about which of these risks are the most significant that you know about, right? There's always going to be risks that you don't know about. And then we can think about how do we address these things? How do we address these risks that significantly impact our service level objective? If I know that I'm allowed to be down 0.1% of the time, and I have a failure mode that's going to take me down for 0.05% of the time, that sounds like that's a significant risk, right? That's half of my error budget. Maybe I'd better fix that. So having that kind of quantitative analysis, even ballpark, can help you make that business case and say, yes, we need to get that on the roadmap. We need to fix it. And actually, once you write down this list, it doesn't matter if it's not going to have an impact if you don't actually do it. So do make sure that you actually prioritize completing that work. And when you learn new things from outages, make sure that you're writing that down on your list of things that I might want to address, and you will have the ability to order them by priority, right? Not every postmortem action item is something that's worth fixing. Some of them are so low in the impact or so low in their impact on how often something happens that it may not be worth doing, and you might be better off working on other higher impact things. But I think that when people do these kinds of incident analyses, one thing that they fail to notice is systematic patterns. So let's talk about systematic patterns. If you do not have observability, that is a systematic risk. If you do not have the ability to understand what is going on in your system quickly and the ability to quickly mitigate, every outage is going to take at least 20 minutes longer. That adds up really, really quickly. And that really goes to the point of thinking about not just, as the sponsor who spoke before me said, how quickly can you get the data in order to understand what's going on in your system right now? But also, can you answer those questions that you have about your system and not just what you thought to instrument at the beginning, right? Can you quickly pick out the signal from the noise as a human being and not having a machine tell you what they think is important? Those are all important factors about making sure that you have appropriate reliability and observability. The other thing that I think is a secret team killer is the lack of collaboration. If you have people who get yelled at every time they say, hey, there's a customer outage, and you look and you say, my dashboards are green, there's no outage, right? Eventually, they'll stop raising their hand and saying, there's a customer outage. and then you're not going to hear about the big outage, right? It's really important to listen to your teammates and make sure that they feel welcome and included in the production excellence process. So I encourage you to, yes, do buy an appropriate amount of alphabet soup, right? If you know that you need something, then of course go buy it, right? Don't reinvent it yourself. But don't buy something just because you think it sounds cool. Buy it because it's actually solving a real business need. And make sure that you're not just buying the tools, that you're facilitating the overall culture and people and processes of your teams by encouraging them to practice good production excellence practices. So to sum up, I would say that production excellence is a great way of really bringing your teams closer together and involving everyone in production. And it requires you to measure when are things too broken, to be able to debug and work together to solve those problems, and then fix those problems over the long term so that they don't impact people as badly in the future. So that's all from me. Thank you very much for having me, and you can see me afterwards for stickers.
Thank you, Liz. Or that mic. I think this happened last year. I had 2 mics at one time, and it was rather confusing. All right, thank you again, Liz. What a fabulous talk. I'm back up on stage again. I'm Debbie Gillespie, one of the organizers, and I'm here again to introduce our fabulous sponsors. Again, like Bridget said, without our sponsors, this conference doesn't happen. So without further ado, come on up. I need whoever's from Red Hat, come to the stage. Everyone else, please come line up, because we need to get through this quick.
Yep, you've got slides up there, so you've got the right ones.
They should be, yeah, they should be on.
Can I, do I have the advancer?
Yep,
Oh, okay.
there's the advancer. Do you want me to grab your laptop? You got it?
Huh? Laptop? What's that?
Right, that's your slide advancer.
Well, all right, on behalf of Red Hat, a warm welcome to DevOps Days. My name is John McDonald. This is Vanilla Kubernetes Does Not Exist. Digital transformation is our world, and it depends heavily on technology innovation. And this puts immense pressure on both developers and operations teams to deliver new features into production at a rapid pace that requires a DevOps process, agile DevOps process to support. Kubernetes has become a platform that's key to DevOps, delivering speed and agility with automation and container orchestration. Now, just like we like different toppings on our vanilla ice cream, Kubernetes is not vanilla. It comes in several different distributions, leaving you to decide which one is best for you. Over the course of the next few minutes, I'll try to raise some points to consider to guide you in that decision. Bringing it back to the beginning where we just had free open source Kubernetes to work with, that was bringing us down the slope nicely, but along the way, of course, we always had a few face plants, making the experience difficult. Now, fortunately, this experience helped us all get smarter, and with help of assistance of companies like Google, we all realized together that Kubernetes is not the end game. It is just the starting point, leaving the realization that for the enterprise, more than raw Kubernetes was needed. This opened up the market to several early startups, all building their own distributions of Kubernetes, investing with different features, investing significant capital as the start of the evolution of building an app platform for the enterprise. As you can see, the stakes were high. Now, if you're going to continue down the do-it-yourself path with raw Kubernetes, the cost of talent acquisition is also extremely high. In a large enterprise, you're going to need several of these resources, making the value proposition of maintaining and managing your own enterprise Kubernetes platform diminish quickly. Kubernetes talent is in very high demand, making retaining that talent very difficult, right? As soon as you get these people seated, somebody else comes knocking on the door. As you can see here, even the enterprise players broaden their reach by acquiring key talent at a hefty price tag. And based on Stack Overflow statistics, this shows that also working with raw Kubernetes can be extremely difficult, as indicated by a significant trajectory in questions on raw Kubernetes alone over a short period of time. And then, of course, you've got the late entry players to deal with that have lack of features. And they'll try to create confusion by detracting focus from the enterprise features that make Kubernetes easy to work with and draw attention back to vanilla, because they don't have those features. And they'll do this through creating myths around vanilla Kubernetes, like it creates the ultimate portability across Kubernetes clusters, it mitigates vendor lock-in, and always keeps you on the latest version. But the reality is, every vendor configures their Kubernetes differently. Every vendor operates Kubernetes in a unique way, and no vendor is really in lockstep with the latest upstream. So taking all these points in consideration, what I'd like to do is walk through a few different distributions to illustrate the point that vanilla Kubernetes does not exist. Now, starting out with free open source is kind of the vanilla baseline. This provides the Kubernetes CLI and API is kind of the foundation. If we look at PKS, right, it starts layering on Bosh for automation, Ubuntu for the kernel, VMware components for networking, and their PKS extensions to the CLI and API. With Docker E, you've got Alpine for the kernel, Calico for networking, UCP for the control plane, and Docker Trusted Registry as their features. Moving up with GKE, we start to bring in a lot of more enterprise features with the App Console, the container registry, and things like load balancer. However, portability is minimized because this has to run in Google Cloud. And lastly, we have Red Hat OpenShift, running on the secure Red Hat Enterprise Linux kernel with Ansible and operators for full automation, and a whole host of completely open source features like Istio Service Mesh, Knative, and Eclipse Shave for complete portability and developer productivity. Another thing to take into consideration as you're making your decisions is how long the notable players have been working with, investing, and contributing back into the Kubernetes environment and community. So as you can see, all distributions are Kubernetes conformant, each with their own features, some which can limit portability. So ultimately, what you want to be making your decisions on is getting the best of both worlds of compliance that gives you portability with features that maintain that portability and give you fastest speed to value. So going back to our vanilla ice cream analogy, taking the points I raised and taking in consideration of features, portability, and cost of DIY, it really comes down to picking a topic that works best for you. Now, I'm kind of partial to strawberry myself, but we'll leave it there. In the end, if you continue to decide to consume your Kubernetes as vanilla without toppings, what you might likely end up with is a rocky road. At the end, what I'd like to do is do a quick plug. We've got a couple of events coming up, if I've got time. If your calendar's open on August 21st at Surly Brewing Company, we have a Cloud Native Day with Burr Sutter and our local talent, Scott England Sullivan, and we have a Red Hat user group on August 13th.
Go.
Thank you.
Thank you, Red Hat. Stop by their booth over in the sponsor hall. Next up, we've got Josh Anderson from F5.
Hello, everybody. I'm Josh Anderson with F5 Networks. You may not know a lot about F5, but we did recently acquire NGINX. Don't worry, it's still going to be open source. 3 important things to know about F5 is 1, we are much more than just load balancing, so please come by and see us and we can explain some of that. 2, we are a strong believer in a supporting community, so I'm thinking about all you guys out there. And 3, we don't do long speeches, so come on by the table, get some free swag. We got some F5 balls, the Nerd Life t-shirts, and an anonymous survey where we're putting pebbles in a jar. It'll make more sense if you come by, so thank you.
Thank you, F5. Next up, we've got Marco from App Dynamics.
G'day, I'm Marco. We're all on a journey. Maybe it's your career, maybe you're trying to bring DevOps a reality in your environment, maybe it's technology, you're moving multi-cloud, but somewhere along that journey, we're all transitioning and transforming our environment. What we do, we're in the application performance management space. So we're going to help you and give you, Liz just mentioned in the keynote about having a common language, not just across sort of the silos, the database guys, the network folks, whatever, but also with your business side. So that's the key difference of, I think, our approach to performance management in general is that we're giving this common language across the board. How many network administrators in the room? All right? Oh, I'm actually surprised that there's one. Welcome. How many Docker or Kubernetes administrators in the room? You didn't realize it, but you're all network administrators too. And that's one of the changes in the environment. You're now setting profiles and items in your environment that when it hits production, when it's running the application in infrastructure, you're making decisions when you write code about what the network environment will be, what the other environments will be. When you need that common language, come and see us.
Sorry,
Yeah,
you're out of time.
I need a clock.
Clock's right there.
Come and talk to us.
All right, Andy, hand it off to him. All right, next up, we have Kendall from Circle CI.
All right. Minneapolis, how we doing this morning? All right, having fun. Guys, I'm Kendall. Like she said, I actually work out of Circle CI's Denver office. If you're not familiar with Circle CI, we're the best CI platform that you've never heard of. We really pride ourselves on being completely maintenance-free and empowering developers to go faster. We actually consistently test about 47% faster than any other CI platform on the market. So I'm here with my buddy Kevin over there. Feel free to stop by the booth. We'll tell you a little bit about the features that enable us to be faster than other CI platforms. In particular, make sure you ask us about orbs. Make sure you ask us about our native Docker support as well as our on-demand resource classes. So look forward to talking to you guys.
All right, thank you, Circle CI. And last up, we have Sean Borg from Magenic.
Hi, everyone. How are we doing today? All right. So Magenic Technologies, not magnetic, not magenta. The name can sometimes be hard to pronounce. And there really is a clock up here, so it's like a post-acceptance Oscar speech, so I got to rush this here. Who are we? We are a digital technology consulting firm. And we bring to the table the right processes, the right strategies, the right people, the experience in order to help you get your digital products and solutions to market faster. So wherever you are, regardless where you are in your digital transformation journey, maybe you're still in those earlier stages of ideation, you're doing rapid prototyping, voice of the customer, or you're still determining your digital product strategy, what the business outcomes would be from that digital product solution. Is it going to save you money? Is it going to make you money? Is it going to save you time? Or you're just in need of a project execution and delivery partner. So regardless of where you are, it is our goal and our mission to get you there faster. We have a booth today. Please come on by. It'd be great to talk to you and get a better understanding of your project initiatives and goals this year and beyond. Thank you.
All right. Thank you, Magenic. Thank you again to all of our fabulous sponsors. Stop in the sponsor hall, visit their booths, grab some coffee, grab some food. Thank you again.
Thank you, Debbie. All right. So I hope that everybody had a very inspiring start by listening to Liz, which was wonderful. I see a bunch of people standing in the back, and I see a bunch of chairs near me. So if you want to take a moment, if you would like a chair to sit in while we listen to the next talk, please walk towards the people who have their hands up. They welcome you as their chair neighbors. We really did provision the correct number of chairs, so I feel bad when I see people standing when there are chairs. Okay, so for our next talk, we started out hearing all about all great things we should do in production. That's true. It's wonderful. Thank you so much, Liz. Now, come on up, Yolanda, because we're going to talk about security. Because you know as well as I do that as soon as people say, oh, those are the things you want to do, but what about security? And Yolanda's here to tell us just that. Give it up for Yolanda Smith.
Well, thank you. Thank you for that great welcome. Well, it's Tuesday morning. I'm a first-time speaker at DevOps Days, and I'm in a dinosaur dress, so killing it. So I get to talk to you all about security today. My name is Yolanda Smith. I am very lucky and privileged that I work for Target, and I'm specifically in the security group there. What I do with Target is I work with developers and I work with product owners to help them secure their web and mobile applications. That's a really highfalutin $5 way of saying I'm a security consultant, okay? And I work for the basically an internal security consultancy, all right? So I hear a lot in talking with those groups. Bridget's telling me to move forward. I hear a lot in talking with those groups, a lot of the same stories over and over, and I want to see if this story resonates with you as well. If we can, there we go. So actually, don't stop me if you heard this one before, because it'll throw off my time. So hopefully this diagram looks familiar to most of the people in this room today. So what we would typically see is that developer would, push some code, it'd have a PR, the PR gets pulled, it goes into the build system, it goes through and passes all its functional tests, its integrated tests, its system tests, because I know you're all doing those. And then somewhere along the way, here comes NetCop, all right? Here comes the security police, making sure that that we're fixing our cross-site scripting and that we're making sure that that no one can actually click on things and make things work anymore, right? I get it. I've heard it. I know it. I've probably said it. All things said, so NetCop comes in and says, "Oh, hey, you gotta stop. We found something on the system. We found something in your application, in your service, in your API. Maybe you're running methods in a way that aren't secure. Maybe you're passing around data in a way that doesn't make sense. But all in all, what could ultimately happen is that a hacker is going to come in. They're going to break into your house. They're going to flip over all your tables, steal all the food out of your fridge, and they're going to punch your dog in the face, and they're going to leave." That's what I call the Oogie Boogie dance, right? It's where we have to come in and make shit up in order to get you to do stuff, right? So what ends up happening in that situation is that the developer comes in and says, okay, I will fix this one thing, whatever it takes. I got to get this through. It's got to go to prod. I've got OKRs. I've got a backlog. I've got to burn through this. So what happens is we put a little tiny patch on that one piece of code, in that one little service, in that one little API, and then it goes back through the system, back through build and test, and we don't hear about it again, right? Or the flip side of the coin is that security decides, you know what, you guys are a little too silly to handle this. All right, so we're going to build our own tools, and we're going to build our own metrics, and our own observability pipeline, and our own monitoring services. And then we're going to inject all of those throughout the pipeline and throughout each phase of the process. And maybe it works for you, maybe it doesn't, but in order to use these things, you're going to have to contort your system, your service, your application, your API, whatever it is that you're building, in order to make this security weird thing work, right? To that I say, hopefully you haven't dealt with this. Maybe you have. I think this certainly sounds familiar to me. All right. The result of all of that is that you end up with a much slower process. You end up having this sort of defensive barrier and this defensive block up against security because they're stopping things from moving forward, right? Well, if you haven't heard it, turns out that most of your peers have, because something like 60% of IT operations and engineering personalities have come back and said that their organizations tend to focus on rapid response to security, to incidents at least. Why? Because we can't get in front of this thing. We're just going to deal with patching it as it comes. But I have some news for you. That strategy, that solution, that approach to solving security issues only actually catches about 30% of all existing security issues that are out there, all right? So you're pushing to production with something like 30% of known issues that are out there. But I really want to focus on this bottom graphic here, which talks about our organization's approach to dealing with threats is reactive, focusing on the immediate threat or hack du jour, right? That's where the Oogie Boogie dance comes into play. That's where somebody heard about Kubernetes that has that's running at the highest level of access. It's running at root. Now we have to go through. Are we running Drupal? Oh my God, we've got Drupal. Let's go off and do this fire drill. See if everyone's got Drupal. Oh my God, it's not patched. Take it all down. And now we've all got this sort of communications breakdown. But is that really an effective method? I would argue no. And in fact, I would argue let's look at the data. Let's look at what has already happened. And let's do a real quick threat model and talk about what's the most likely scenario for most of the people in this room. For those that don't know, a threat model is really just a quick way, well, maybe not so quick, it's a way to understand who and what might be coming at your organization, right? And the vectors that they might take. Where are your vulnerabilities that you know about, right? So chances are, there's a 50-50 shot that hacking will be the primary attack tactic, right? 50-50 shot. That means that it could come through social means. That means it could come through errors or misconfigurations. It means it could come through any number of methods. But there's a 50-50 shot that hacking is going to be the way that someone gets in. That means someone's going to take a hammer to your application and do something bad to it, right? In those cases where hacking is the primary tactic, 60% of those breaches will actually involve stolen credentials. I'm not going to bring up Capital One. Don't ask me about Capital One. But wink, wink, nudge, nudge, guess what I'm thinking about. So 60% of those will involve stolen credentials, meaning that some other breach happened, and then we're going to take those credentials, and we're going to try and use them against your application because users tend to repeat things that they know and that are easy for them to remember, right? There's an almost 70% chance that that breach is going to be perpetrated by someone from the outside of your organization, right? Insider threat is a real thing. Insider threat actually happens, right? Misconfigurations are a key contributor to insider threats, but for the most part, we're going to expect to see our issues coming from outside. So it's going to affect your production environments. And then finally, after all that, why are they doing it? They're doing it for the money. That's what it's about. It's typically about the money. Unless there's anyone in here from the government of St. Paul or from the state of Minnesota's office, you're worried about someone coming after your money. I see one person back there that's, that's from the government. If you're from the government, chances are it's probably going to be like ransomware or even maybe a nation state. But that's a really sort of odd corner case. So I have all these big scary numbers up, not to scare you, not to put on my own version of the Oogie Boogie dance. So what am I really saying here? I'm saying that nothing matters. That's not what I'm saying. And if you thought that's what I was going to come up here and say, don't worry about security, psych, psyched you all out. What I am saying is that more security is not necessarily more secure, right? We have to figure out a way to put the right controls in the right place that allow us to go fast, that allow us to do what we need to do to deliver our features, to have resilient systems, to actually provide value to our customers and to the people that use our services without having to just pile on all this useless stuff that may not matter. So it's important to understand where those perspectives actually come from. Where are those personas and who are the groups involved in forming the idea that you have to do all the security things in order for you to be secure? I would argue that there's three groups that we want to talk about. First group we want to talk about is engineering. Some of the folks in this room, some of you are operators, some of you are engineering operators. But what I hear most often from the engineers that I work with is that the guidance that they get from security is way out of date. It's not applicable to their tech stack. It doesn't necessarily convert or make sense for what they're trying to do. And the design that they would have to do in order to actually make the security advice work means that they would have to completely contort their entire posture in order to facilitate that change. A lot of times the tooling that we introduce from a security perspective, it ultimately ends up impacting product performance, and it ends up impacting our ability to deliver that customer experience, right? Because now we're sort of contorting ourselves to make it work. And then, for as much as I love doing the Oogie Boogie dance, I will tell you that engineers have gotten really good at calling me on my shit. Right? They are really skeptical for the most part about whether or not this threat is applicable. And does it make sense for them to fix this thing at this time in this place, right? Are we talking about a nation state and it's coming up in a penetration test? Why are we actually spending time on that, right? Well, the other group that I think we need to address is product, the business. The folks that are saying, hey, we want to provide this service, we want to provide this feature, we want to provide this experience, right? A lot of times what I hear from those folks is that security is way too late in feature planning. And because it's not necessarily considered part of the feature planning process, it ends up being pushed off onto engineering as technical debt. It ends up being pushed off in engineering as part of the cost of doing business, right? Because we can't necessarily quickly and easily measure the impact on revenue, the impact on customer acquisition, and on feature adoption. It ends up being an engineering problem to solve, and so product doesn't necessarily want to get involved with security. And then for my part, what I actually hear a lot and what I actually tend to feel when I'm in this scenario is that I'm not necessarily invited to participate. Security ends up being late to the table, and if they're at the table, they're sort of regarded with suspicion. If anyone here has read the State of DevOps report from last year, they're still doing a survey for this year, but the State of DevOps report from last year calls for security to actually get involved in stages 4 and 5 of the DevOps cycle, the maturity model, right? I think that's way too late. I think we should be working to pull security forward into stages 1 and 2 as we're starting to build out our pipeline and our build system. Because security ends up being involved way too late, it ends up feeling really reactive, right? It ends up feeling like, oh, well, we have to fix everything because we caught this one thing, right? And because of that, because we're only finding out things after the product's already built and you have to go to prod, or we're finding out things at the end of the development cycle, every single thing that we do find ends up being sort of a canary in a coal mine. It ends up being a situation where I feel like this one thing is indicative of a whole host of other problems. I will tell you, my personal take is if I see a product or a service that doesn't do session management right, I will dig in and dig in and dig in, because session management for me is that red flag where I say, if we can't get this right, we're missing other stuff, right? So there's a lot of different perspectives on security. I think that everyone collectively recognizes that security is important. So we have to come to some level of common ground, right? And I think to do that, we first have to recognize, understand, acknowledge the fact that security rots. The thing that you deploy on day 1 will be less secure on day 10, less secure on day 50, less secure on day 365. It rots. Why? Because it's exposed to the rest of the world, and the rest of the world has an opportunity to hammer on it and to try and break it. It will rot. I used to tell people security rots like milk, but it's more like security has a decay rate. The next thing we have to acknowledge and recognize is that security is a spectrum. It is not a binary, are you secure, are you not secure? It depends upon who you ask, it depends upon when you ask, it depends upon the actual situation that's involved, right? Who's affected by a security issue. Finally, we have to recognize that security doesn't exist outside the product. Anyone who has spent any time with me at Target knows that I am inherently suspicious of dashboards and metrics that are sort of feeders unto themselves. I call it security people doing security things to do other security things, right? If it doesn't support or serve the product, there's no security there. There's no security to talk about. Okay, so if we can all nod our heads up and down and recognize that, yes, those are the things that we all agree to when we talk about what do we have to understand about security. Now I think we can move forward and say, how do we know how much is enough? So I've got a couple of pillars that I'd like you to consider. Because I think rather than moving to having a situation where we say it's either all or nothing, or it's something where you have to do whatever security says you want, I think it's a partnership involving your customers and your business and how you construct and operate your pipeline, right? That's how you right-size your security. So these are not novel. I mean, I'm not going to win a Nobel Prize for coming up with protect the customer, protect the business, and protect the pipeline, right? These are fairly straightforward things. And when I talk through them, you're going to be like, Yolanda, this seems pretty lame. Like, maybe not lame, but you're going to be like, Yolanda, this seems pretty straightforward. Why is it that this is so important? It's important because ultimately, we're still seeing S3 buckets sitting out there with customer data. We're still seeing GCS buckets that are sitting out there with customer data. We're still seeing Kubernetes out there that have root enabled and that allow you to actually move from container to container unmitigated. I think the very first thing The very first pillar, the number one thing that any one of us can do in this room and we walk away with is to figure out how we better protect our customers. How do we move from talking about security to moving towards something that talks about safety and trustworthiness? Ultimately, that's what your customers are providing to you. They're handing you money, and they're going to hand you their data, and they're trusting you to do the right thing with it. They're trusting all of us to do the right thing with it. And I'm not sitting up here wanting to browbeat you, but we have to question ourselves at every single turn as to what that really means. What does it mean to protect our customer? It means we're not going to embarrass them. It means we're not going to inconvenience them. And it means that we're not going to harm them. I will tell you, as a victim of stalking myself, the thing that scares the crap out of me is location data and the proliferation of location data. How in the heck are we making sure that we are doing the right thing with that data? When I talk about things like inconveniencing them, if a breach comes up, what are we going to do to make sure that they aren't having to sit on the phone for up to 24 hours, take time off of work, spend their own money trying to recover their credit, trying to recover their identity? That's ours to own. That's our burden to bear. And then we have to understand how we measure that trust, and then how do we know when we lose it? Does that loss in trust come from a lack of adoption? All right, does that come from a lack in sales? Does that come from a drop in people wanting to say good things about our brand? That trust is immeasurable, and yet it's so important. So practically, what questions do we need to be able to answer? And I'm going to focus on data here, because this is what the customer is giving us. This is the part of the contract that they're providing, right? What data do we need to have in order to deliver an experience? Ultimately, does this data already exist someplace else? I'll tell you, the more places data exists, the more places you have to protect it, the more places you have to watch it. How long do we want to keep this around? How long do we want to keep this data, right? And who ultimately gets to have access to that data? Do we understand the effects of inadvertent exposure of that data? And then finally, how are we measuring if and when this exposure actually occurs? Next thing we want to do is protect the business. Most of us here work for companies. Companies want to make money and generate revenue. I'm a big believer that if we want to pull security into the planning phases, we have to be thinking about it from the start of the business. We have to think about it from the start of the feature, the start of the requirement, the start of the actual request. Right? So strategically, what does that actually look like? It means we go from gaining and maintaining the customer's trust in protecting our customer to now expanding upon that trust to grow the revenue stream. It's doable. Security doesn't just have to be a cost center, right? But we need to be very methodical and deliberate in understanding what things we will do and what things we won't do. And I love that Liz brought up the idea of documentation in her discussion, because we need to document those things as part of the roadmap, as part of whatever it is we're going to say that we're going to do. We're going to do this. This is how we're going to secure the customer. This is how we're going to make sure this data is good to go. And oh, by the way, we need to make sure that we're planning for the lifetime of that feature. Security is a lifetime obligation. Remember I said that security rots, right? So as part of the product planning phase, there needs to be something in there that talks about end of life. There needs to be something in there that talks about how we ultimately are going to continuously care and feed for this feature, and security is part of that care and feeding. As I stated, security doesn't necessarily have to be a cost center. It can ultimately provide a distinctive competitive advantage. But we need to understand how we measure that advantage over time. And then from that point, once we get those things together, then we need to talk about what I suspect that most of the people in this room here care about, is protecting that pipeline. When we talk about protecting the pipeline, it's important to recognize who's a part of the pipeline. So how many straight up developers do I have in the room? Raise your hand, please. Straight up developers. How many operators do I have in the room? How many product types do I have in the room? Architects. How many support staff do I have in the room? How many security folks do I have in the room? Okay, great. There's a whole host. Any CEOs, CFOs, C-level folks? Okay. It's important to recognize that it's not just the infrastructure. It's not just the gear. It's not just the technology that's part of the pipeline. Ultimately, it's your ephemeral environments. Yes, it's your containers. Yes, it's your laptops and your operating systems. Everything that is part of actually touching and building the product, including your supply chain. That's an important note. Including your supply chain. Those are all part of the pipeline, including the people in this room, right? The question that I always ask is, how much do we actually need? How many people actually have to touch this in order to deliver this experience? Because the closer you are to that product, the closer you are to delivering on that experience, the more protections that we're going to ask for you to adopt, right? And then the question becomes, what really motivates those pipeline decisions? When I talk to the folks that I work with, a lot of times is, what's easy? What's the easiest thing? The easiest thing for me to do is to put this data in a GCS bucket and float it out, and then that way anyone can get access to it. That's the easiest thing for me to do. It's not the right thing for us to do, ultimately. And we have to be able to continuously measure how we're pushing that data, how we are managing that pipeline, and then understanding the integrity of the pipeline itself, because that's part of what makes you secure. You'll notice here in this slide that I talked about, that I pulled up the Reddit hack from 2 years ago. They called out the fact that they got hacked because of a woefully insecure, woefully according to Wired, woefully insecure two-factor authentication setup. Essentially, they were using their phone numbers, SMS, in order to provide a secondary means of secondary means of identification. Now, in my security brain, I'm like, haha, they suck, right? But on the same token, I'm like, flip side of that coin, but that's what was available to them, and that's what was easiest. So, understanding that's what was easiest for them at the time, what steps can we take to make sure that we are protecting and providing those same easy solutions and those same easy alternatives without necessarily hurting the pipeline itself? Okay. So when it comes to tactics, when we talk about how are we going to actually go about protecting the pipeline, I already stated, if you're part of the product development process, you're part of the pipeline. That includes the people. And that includes the process as well. The closer you are to the product, the closer you are to raw product, the more protections that I expect you to have. Guess what? If you're, and you might not like what I have to say, flip a table, flip a chair. The closer you are to that raw product, I do expect you to have two-factor authentication turned on. I do expect you to have full disk encryption turned on. I do expect you to use a VPN when you're in a public space. I expect that. I need that. We all need that because you are part of what an attacker is going to go after. Right? The other piece of this, and this really comes back down to the technology itself, is that it is possible, and we should make it a point to continuously inspect and interrogate for security issues at each stage of the build process. Look for secrets at stage 1, look for secrets at stage 10, look for API keys at stage 1, look for API keys at stage 15. We have to keep looking for it because there's opportunities at each and every one of those stages for us to actually infect that pipeline. I like to think of the pipeline as kind of a clean room. Our objective is to maintain the sterility of that clean room from end to end. And we can do that if we're constantly checking again and again and again. And then finally, it's important that as we're seeing these little blips on the radar, that we recirculate those blips back into our ops process, back into our observability pipeline, back into a situation where we can go back and say, hey, it seems like we're seeing secrets show up over and over and over again. How is it that we can make sure that we either strip this out or educate our developers to the point where they're not, that they have a solution to not add those secrets in the first place? Okay. You got this, right? You got it. Totally under your thumb. I'm going to wrap this up. I do think it's possible for you to offer a unique, personalized, secure experience for your customers. If you think of your customers and you question at every step of the way, every step of the build, every step of the delivery, at every ephemeral environment, every single stage. Question, question, question. Are we doing the right thing by our customers? They're giving you money. They're giving you their data. Let's do the right thing there. Secondly, I do think it's possible for you to use security as a revenue driver and not just as a cost center. And ultimately, what that allows is for you to build a system, application, service, API, a pipeline that is from end to end more resilient, from end to end less prone to failure, from end to end much more available to your customers than not. And yes, I do think it's possible for you to build a screaming hot pipeline that is also security sensitive. If you question over and over and over, hey, are we doing this the right thing the right way? Are we actually looking for security issues and recirculating those things back into the pipeline? Okay. So you see, I threw up a couple of references and resources here. Throughout the presentation, I had a few reports and charts and things like that. If you want access to those, they are all listed here in the references and resources chart. And if you like to fight me on the internet, you can do that. I'll fight you back. Okay. My name is Yolanda Smith. Thank you all so much. This was a blast. Thank you, Bridget. And have a good con.
All right, thank you so much, Yolanda. We have about a 20-minute break. If you want to hit the restroom, visit the sponsor hall, don't forget to enter all their raffles so you can win fabulous prizes. We will meet you back here at 10:45 a.m. You definitely want to hear about collaboration and collaborative automation from Jessica Kerr. So come back at 10:45 a.m. Thanks. All right, get your seats now because we're going to get started again here in just a second. Quick announcement. We found a backpack. It looked like it had a boarding pass in it for someone named Allison. So if that is you, or if you know who that is, and you would like to go talk to them and maybe tell them what Allison's last name is at the info desk, Allison's backpack could belong to someone, hopefully Allison. I'm just, OPSEC. Anyway, so just after that quick announcement, let's hear from another sponsor.
Hello, it's me again. We've got more sponsors. This time we have Janani and Kate from Optum.
Hi, good morning all. Thank you so much for joining us. I am Janani Patangi, a distinguished engineer from Optum.
I am Kate Agnew. I'm a senior manager within platform engineering. And thank you so much for allowing us to be here and tell you more about the great work that Optum does. Oh my God, how does a clicker work? I swear I work in technology. All right, so when I first started at Optum a couple of years ago, my mom didn't know that Optum was a company. She didn't know that it was a local company, and she didn't know that it was a part of a Fortune 6 organization. I'm actually not sure that she knows that now, but I'm here to tell you all a little bit more about how the two businesses that make up United Health Group really improve the lives of those through healthcare. So we have United Healthcare, which is really focused on the health benefit side of the world. And then we have Optum, which is the health services. So what that means is ultimately Optum is the technology organization for United Health Group and for other businesses. Our mission is to help people live healthier lives and to help make the health system work better for everyone. Our core values listed here at the bottom are really important to us, especially as we consider the technology solutions that we develop. So we improve experiences, outcomes, and try to reduce the costs of healthcare. And what that means is that 4 out of 5 providers in US hospitals use us for their patient care. 4 out of 5 Fortune 100 companies have us as their healthcare solution for their employees. And we serve over 127 million individuals annually.
Okay, so let's see what we are doing at Optum. So at Optum, we are pushing the boundaries of traditional medical care with a combination of data, analytics, and the emerging technologies to reduce the cost as well as improve the patient experience. So with that said, I have listed all the emerging technologies at Optum with a roadmap of current and over the 2 to 5 years, starting from graph all the way to the quantum. So as you can see, we are applying deep learning and AI models to automate our claims payment so we can reduce the manual claims adjudication, as well as our blockchain consortium is leading the healthcare industry with production pilot right now. And how many of you are using speakers, smart speakers at home? We do have Alexa and other skills available for both internal as well as the external use cases so that we can provide information on the go to reduce the patient Q&A in terms of providing the Optum Bank, for example, what is my HSA and HRA related questions. So these are some of the things that we are working on right now. So with our infrastructure and technology, we have a hybrid cloud strategy with 99% of our workloads running in our own data center, and it's secured, and we support about more than 150 petabytes of data covering the 127 million individual membership that we support today. And as you can see, we spend about $3.5 billion annually on technology as well as innovation. And we also are working on the next generation of healthcare platform. The goal is to provide access to the data in real time using open source technologies like Kafka as well as Cassandra. So in our data centers, we support all the way from mainframe and to the next generation of container platforms like Kubernetes, as well as we have our own GPU infrastructure for our own deep learning and machine learning and other use cases, and FPGA for our genomics use cases.
So if any of this is at all interesting to you, we invite you to check out our booth over in the hall. You literally can't miss it. It's the first one when you walk in. My team in particular is hiring, and I'm working on a lot of that healthcare platform work, leveraging Kafka and other streaming technologies to move our data into near real time. So come join me, come find me, talk to Janani. We are here and look forward to chatting. Thanks.
Thank you all.
Thank you again, Optum.
All right, thank you so much. So, again, make sure you visit our sponsors in the sponsor hall. Next, we're going to hear from Jessica Kerr. I asked Jessica to come speak. Please join us, Jessica. I asked Jessica to come speak because I'm really interested in everything you're doing in your organizations to make your collaboration work better. And Jessica is an expert and has some really interesting insights on this topic. So without further ado, please give it up for Jessica Kerr.
Thank you, Bridget. Good morning. Today, I'm excited to speak to you about principles of collaborative automation. I have 4 principles this morning and also 4 precautions or ironies of automation. These come out of the resilience engineering community and studies of collaboration between humans and also between humans and software. Because we don't only collaborate with people anymore. We very much collaborate with machines, computers, and programs. We do this at many scales. So on one hand, you've got like the place where the people just exist to help the software run. So in a Patriot missile, for instance, this is not a thing that could exist if humans had to make the decisions of where to go. The software on the missile is deciding that. And then somewhere back in a control center, there's a human that's somehow supposed to check on it and be there in case somebody needs to be blamed. And in machines, or in factories, you've got like big automations and nuclear power plants, and the humans there are there to help the machines in case anything goes wrong and to problem solve. In the middle then, you've got the business applications where, we write a lot of these, where people have to work with the software in order to do their job. The people can't do their work without the software, and the software can't do their work without the people. And similarly, there's software that I would have a hard time living without, such as Google Maps and navigation. I can still read a map, I'm pretty sure, but my little sister, I don't think she can, because these programs have become essential to our world. And then there's the little ones, the little games, the little Southwest app and things like that, yes, they're convenient, but we could do our work without them in another way. Similarly, as developers, we have all of these. So if I'm a developer whose job is to operate useful software, which is what I consider success, then, I'm here because of the software. And so I'm in charge of that, but it has the purpose. And then there's all these tools that I can't do this job without, such as the source control, my IDE, the deployment system, the infrastructure I run on. These are essential pieces of software. And then there's the little ones, like grep. I don't know how I would do with my job without grep, but I'm pretty sure I could figure something out if I had to. And these are little ones that we can add more of those all the time. And the difference here between everyone else and the development team is that we can change this software. The software that we operate, we also change. So if it's hard to operate, that's on us. This is kind of the point of DevOps. Similarly, we can update our deployment system. At the very least, we can add automated tests and checks and linting to our build scripts. We can customize our IDE. We do a lot to our local environment because we both work in the computer and we work on the computer. So it's different for us because we actually can change the software that we work with. And so us and the software form one socio-technical system. The code is on our team. And this is a special kind of system. It's a learning system made of learning parts. There's a word for that called semathecy. Learning system made of learning parts. We learn from each other, and we learn from our software when it throws exceptions, and our software learns from us because we change it, but we don't learn anything without our tools, without our observability and our log traces and PagerDuty. So we need all of our tools to get the learning from the software to us across and that changes the flows of mutual learning. This is a system based on flows of mutual learning between us and our software and among us. And the tricky bit is this line of representation in between, and this is why our tools, including grep, are so important, because they let us see into the digital world to learn from our software and to change it. So we're unique in this. We and our software are engaged in the socio-technical system in joint activity. Now, joint activity means that we're working toward a common goal and our tasks are interrelated. So if we want to have dinner together, and I'm like, okay, you bring the meatloaf, and you bake some bread, you bring a pie, and I'll do the mashed potatoes, and we'll meet back here at 6 p.m. That's not joint activity, that's just coordination. Unless we're sharing a kitchen. If we have one oven and one counter space, and maybe we want to make just one common trip to the grocery store, suddenly our tasks are intertwined and we're engaged in joint activity. Software development is all about joint activity. Our tasks are incredibly interdependent. There are 4 things that we need for joint activity to work, and I'll go through each of them. The first one is the basic compact. This is an agreement, usually unspoken, that we're all going to work toward a common purpose until further notice. The until further notice part is important, because if we quit our team, we don't just ghost, we resign. If we're not going to be in today, we call in sick. There's a finer resolution to this too, because I might say in stand-up, okay, my kids were up all night puking, and if I yell at you today, I'm sorry, it's not you, it's me. There's like a degree of collaboration that we're not quite ready for that day. And we can be specific like that. As a counterexample from another industry, okay, one time there's this airplane, and there's a fuel leak. And it would have killed them if they hadn't noticed. But they got lucky, and somebody happened to notice that the fuel gauge on the left was going down when the engines were drawing from the right. And they're like, well, that's weird. So they take a casual stroll down the aisle, and they glance out the window, and oh, yep, there goes the fuel. Keep a straight face. And only then do they go back in the cockpit and notice that the autopilot is doing this, because it's gradually compensating for the increasing weight imbalance. And it's not telling anyone that it's working that hard. Okay, collaboration is not about try harder. Collaboration is about, yo, this is harder than I thought I was. Could I get some help over here? Before the plane crashes. In our software, in our production software, this is things like health endpoints aren't yes or no. A health endpoint says, okay, I've been up since this time. I'm serving requests at this rate, and I've got this many database connections open, and my downstreams are responding at this rate, except for this one, which I think is down, so I'm using this backup stuff. Detail. And then we can work with that. We can help the software. So we have to make the health endpoint so it can help us help it. There's more to the basic compact. It also includes that when the other pillars of joint activity start to break down, we work to restore them. Liz talked about this a little bit. When we lose communication, we actively restore it. This means don't swallow errors. If you have a weakness, you want to surface it to your team, a weakness or something that's harder than you expected. Now, yeah, okay, don't show the errors to the end user usually, but do show them to the humans on your team, because that's what humans are good at, is everything you haven't programmed into the computer yet. There's another concept here of the difference between rely on and work with. I don't rely on my coworkers. I don't rely on my coworkers, my team members, to be around 24/7, to answer questions at all time, even to be in a good mood at all the time. Instead, we work together so that somebody's on vacation, somebody's sleeping, this is fine, but as a team, someone is available to answer the pager 24/7. Someone is available to answer questions in Slack during business hours. Collectively, we can be reliable, but individually as a human, that's not a thing. So we work with each other to present a more consistent front to the rest of the world. This applies to our software too. So if any software you operate, you don't rely on, you work with it. If you have queuing as part of your system and you operate Kafka, you can't rely on Kafka. 2 or 3 months, it's working fine, everything's great, all of a sudden, oh my gosh, and you're Googling, how do I restore these lost messages? Because you have no idea. You have to work with Kafka while you operate it. As opposed to, if you get Kafka as a service, then worst case scenario, you talk to a person, because resilience isn't a thing without humans in the system. And those humans are regularly restoring messages that were lost, and they actually remember how to do it. They don't even, well, maybe they don't even have to Google the syntax for it. So rely on versus work with. Work with your team members and your software. You don't depend on any specific instance of your software to be up all the time, but collectively it can be 99%. All right, so that's the basic compact. The next thing is mutual predictability. We need to be able to roughly predict what the other people and software on our team are going to do in a particular situation. This gives us confidence and trust. So in stand-up, if I'm like, okay, I'm working on this ticket, and I think I'm going to add a join table to hook these two things together, and somebody else is like, you're going to, what? Have you thought about what that's going to do to the number of records? And so when we notice that there's a loss of predictability, we work to restore it as part of the basic compact. Counterexample from the real world, Apple likes to send messages from me, stuff like, kinda gave me a drawing, kinda is sick today. No, Apple, I have a daughter and her name is Linda. Also, in like automated car driving, right? They've got the cars that are doing this driver assist thing, and one of the things that they'll do is like if you get too close to the car in front of you, it'll hit the brakes. That might be useful, but not if you were trying to pass that car. So the trick is you're accelerating to pass that car and you use your turn signal. Your turn signal can tell the automation your intention, and that can help it predict what you're about to do and not slam on the brakes. That's important. A trivial example from real software. The other day I installed Git on Windows and it pops up one of those old style installers that's like, okay, we're gonna install this. I'm gonna ask you where you want it, and I'm gonna ask you some more questions, and then I'm gonna install it, and then I'm gonna tell you what I did. And it's boring, yeah, but it's predictable. It's kind of comforting that way. Builds trust. More mutual predictability in our automations, especially the automations that we write for ourselves. We need to be able to understand their state, actions, and what is about to happen. This means I don't want any AI. I don't want any machine learning, and I don't want any natural language processing in my automations that I use for myself. I mean, maybe in production software, okay, that's different because there you're justified in working hard enough on it to get past the uncanny valley of, it did what? But not locally. For instance, we used to have, we still have an automation at Atomist that if I put in a commit message that doesn't meet coding standards, it yells at me. If I'm on a branch, I might fix it. But the thing is, the capital letter stuff works fine. Does it start with a capital letter? Yes. But it thinks that I'm not using present tense if there's a single past tense verb anywhere in the commit message. That is not a good use of NLP, and we've turned that off because we're not going to work hard enough to get it right. It wouldn't be worth it, so get it out. Right. I also want my automations to be accountable, not for outcomes, that's just silly, but accountable to tell the story of why they did what they did, because that can restore predictability. Accountability is about telling the story of why something happened, about being understandable. This one time, I worked at a payment processor, and there were a lot of transactions marked as fraud from like the Netherlands or something. And it was like, well, that's weird. And then, thank you, European Union, for passing laws that require this. They added functionality in the machine learning system that would make it say which rules fired, what percentage, so you could see why it rejected them. And it was like, oh, the country code is between 35 and 37. Okay, 35 is like Nigeria, and 37 is like Liberia. And then right in the middle, there's the Netherlands. And once you see that, you're like, no machine learning feature. That is an enum, not an amount. Quit it with the ranges. You need your software to be explicable. to talk to you about what happened. And even better, can you make it teach you what's going on? That's the pinnacle of observability that Liz talked about this morning. So in Adamus, if I come in as a new person and I make a commit and I push it somewhere, then our delivery automation pops in and it puts up this message and it's like, okay, I'm going to do some auto fixes, I'm going to analyze the push, I'm going to fingerprint it, I'm going to version it, I'm going to do a build, blah, blah, blah. And then each of these turn green in the message as they complete. You can click through to see the log. I'm working on adding a link to the log that will let you go straight to the code that made that decision, because we as developers can change our own automations and make them teach us what they're doing, and that is awesome. Okay, next, mutual directability, because once you can predict each other, you can also change what each other's gonna do. So I can say, have you thought about how many records are gonna be in that join table? And I can be, oh, I didn't think it would be unreasonable. Let's discuss this further. In the computer, this means what you don't want is to walk into an office and like apply for a driver's license or something, and the person's like, computer says no. The computer, especially when we're developers, should not be in charge. Positive example from production software. I used to work in an insurance company, and we had this big system. It was written in Java like around 2000, and it had no business still being in production because it had a caching layer that just plain didn't work. It did not work. And the 70 users, and we had to restart it every night. It was insurance, so they didn't care. And it was like, oh my gosh, it wouldn't have been sustainable, except it had the most beautiful admin screens ever. And as a developer and first line support, because that was the same thing, the quoters would call in and be like, oh, I got another exception, and I'd go and I'd open up and it'd show me what was in the cache and who else had a cache record for that, and I could change it or clear it out and be like, oh, try again. And so that kept that system limping along for years, because I could really see and manipulate what was going on. It was directable. In my software, I want my automations to present and explain choices, not to make them for me. A lovely example of this is navigation. It used to be that you'd have navigation in your car, and it would tell you where to go, and it didn't give you choices. It was just like, please do a U-turn. Please do a U-turn. But these days, it's much better. So if I go to Google Maps and I'm like, yo, I need to get to the airport, it's like, okay, here's my recommended route. But you might think you could take Highway 40, but that's 5 minutes slower because there's this traffic right here. You can see your alternatives and you can see why it's making these choices. Beautiful. I also love auto-completion in Gmail lately, because you type something, it's like, oh, I think you might want to say this, press tab to accept, or just keep going and I'll get out of your way. Unlike autocorrect, which ducking goes back and changes what I already typed. I hate that. Yeah, there's another weird thing. Here's a strange property of negotiations. The party with less flexibility has more power. So if I'm a software vendor and you're a manager of a development team and you want to buy my Alphabet Soup tool, and I want to sell it to you for $30,000 a year, but you're only authorized to spend $20,000 a year, then either I come down to your price, or you're going to have to go back to your superiors and the finance people and get authorization for this, and maybe we'll have another meeting next week. Meanwhile, I'm the one with responsibility to meet this quarter's numbers. You have the power because you have less flexibility than I do. And the same happens with computers. Now, people are maximally flexible. That's why we make great receptacles for blame. There's always something we physically could have done differently, but why would we have done that? But the computers are not. They're never going to be fully flexible. And so we need to make sure that our automations, they're never going to cover every case. They just need to get out of the way. As Liz said earlier, you can't automate anything you don't already know how to do, so just let me do it. A good example of this is dry run options in things like Make, and a lot of programs have this, where it's like you pass the dry run flag and it just tells you what it's going to do, and then you decide whether to do that, or maybe you'll just do a couple of those steps yourself. That's a good way to keep the human in charge. Okay, last one is the hardest. common ground. Common ground is defined mathematically as the things that we both know, and we both know them, and we both know that we both know that we both know them, and we both know that we both, so on infinitely. Now, mathematically, this is impossible to achieve in the presence of uncertain message passing. Fortunately, we're humans, and there's such a thing as good enough. So if we're all in a meeting and we discuss coding standards and we decide to change one of them, then everyone in the meeting assumes that everyone in the meeting knows this stuff and it's considered common ground. And the basic compact says when we notice that it's breaking down, we restore it. So as we're pairing and I start violating that code standard that we just agreed on, you're like, Jess, didn't we say we were gonna? And I'm like, oh, did we? Thank you for informing me of that, because I must have been asleep. The other thing about maintaining common ground is we want to share information with each other and the team, but not all the information. That's the same as no information. No, you don't need my dashboard that helped me in the last incident. I stream on Twitch sometimes when I'm working because I'm working on open source and I can. And does the rest of the company watch? No, they could, but they've got their own things to do. Part of conserving or preserving common ground is respecting each other's attention and giving people the right information. Counterexample from healthcare is when the nurse logs into a patient record and they get 6 pop-ups. Okay, just let me do my job. Well, some of those pop-ups are crucially important, like this medication and this medication could have this really bad effect given together, and you should talk to the doctor about that. But if that's right next to, oh my gosh, we're almost out of bed sheets, then the nurse isn't going to see that. Respect each other's attention. This is very important in your pages, in your log messages, stuff like that. One thing that I love lately as I'm working toward common ground is I'm trying to learn front-end development. Hint, it's so much harder than back-end. But one thing that really helps is between me and my software, a breakdown in common ground is present whenever there's a bug. I thought it works one way. It actually works this other way. Oh, we better talk about that. And I really appreciate the many levels at which I can restore common ground with the software. So in the browser, I can look at the page, but I can look at the HTML and the elements. I can look at the React tab in Chrome debugger. I can see the styles. I can see the JavaScript that my TypeScript compiled to, which is very readable JavaScript. JavaScript, it's the bytecode of the web. It's so much more readable than JVM bytecode. I like it. I can see the JSON going back and forth. All of this stuff that's human readable is valuable because it lets us restore common ground with our software at many levels. So I appreciate that. More on common ground. The thing is that our limitation as developers is not what we can do, it's how much we can know, because we cannot have the whole system in our head at once. It's too complex, and that's okay. And that's good, because we need complexity in our software. That's why it exists. Yes, some of it is unnecessary, but some of it is our entire reason for existing. John Allspaw talks about how success begets complexity, which begets success. Because the purpose of our software is to take a bunch of knowledge out of the heads of the people who are using it. So I don't have to know how to read a map. More specifically, I don't have to read a map while I'm driving. And that is valuable. Also, for resilience, you need complexity. You have to add layers. You have to add complications to build that reliability on top of individually unreliable parts. But the more success you have, the more customers you have to support, and the more backwards compatibility you need, and the more complexity you get, but then you support all those things so you can have more success. Complexity is essential. Don't try to stomp it all out. Some of it, yes, but most of it, no. The trick is to balance it with increased feedback. And that's where our observability comes in. Care about the operator interface. Okay, the operator is you. Your experience matters. One easy trick for this. Error messages are a great time to restore common ground. When you thought it worked one way and it didn't, and it tells you with a help and guidance message. See, just rename it. Naming is powerful. And suddenly, you have something useful and a way to restore common ground with the person who's trying to use whatever it is. I love those. Okay, common ground is really hard, but it's incredibly valuable. So work at it. All right, those are the 4 pillars of joint activity. We need to surface weaknesses within our team, display and explain our plans, especially in our automations, keep the human in charge, and give me a, wow. And find it. Okay. Oh, we got it. Okay. All right. Okay, that's a new one. All right. So do tell me what you're doing, but be careful with my attention. Now it's time for the gratuitous cat picture. This is Pixie and Odin helping me prepare this talk. They are remarkably talented at being in the way. And now it's time for the 4 ironies of automation. These are things that people think automation will make easier, and it actually makes them harder. First, you think that the smarter your automation, the cleverer your AI, the less intelligence you need in your human operators. And the opposite is true. Okay, automation does not save you money. It adds capability. It means that you can get those approvals to your customers in 2 seconds instead of 4 to 6 weeks. But behind the scenes, you've got people operating that software who understand all the intricacies of the approvals. You actually have to know more to operate smarter software. You need to be trained in problem solving, not in procedures. Computer can do the procedures. People need to solve the everything else. That's what we're good at. So no, your people get more expensive, sorry. The next one is you want to care about the happy path, because that happens 90% of the time. But it's 1 in 1,000 possible cases. So the exceptions are the rule. Start from the exceptional case and make it just not the end of the world. Worst case, fall back to a human. That's what we're good at. And especially in automations that we write for ourselves, well, we could have done it. I mean, we knew how to do it already. So just make sure the error doesn't delete anything permanently. And then let the human compensate. And then we can gradually increase the cases that we have automated. Third, watch out. The more of the easy stuff you automate, the harder it is when you get to the hard stuff, because your brain isn't in the game. You're off thinking about other things, which is great. But then when you do have to deal with Kafka failing, and so far it hasn't failed yet, it's going to be really hard. And that's why specialization can help a lot, because it lets people be in that mode of dealing with the hard stuff regularly. So be careful with that. Finally, we've talked about this one already. The less flexible party has more power. Your automation's never going to be fully flexible, so keep the human in charge. Make the best path obvious and easy, but never mandatory. As developers, we are uniquely able to overcome all of these ironies of automation in the way that people who can only use automation and can't change it can't do. We can overcome these because we're all part of the same system. And we can choose to put things below the line where we want speed, power, and consistency. Yes, I want like code style consistency. Don't make me do it. Just put that in a robot, please. And then when stuff requires social skills, when it's new, when we need to solve new problems all the time, that's what people are good at. We're the ones who know why we're doing this at all. And that's important. So as developers, we get to choose which side of the line each task can fall on, and we get to work on these flows of mutual learning. Because the thing is, we need to keep learning because it's never going to be perfect. Your coworkers are never going to be perfect. Your automations are never going to be perfect. So make them collaborative. A lot of thinking went into this talk, very little of it mine. Here are some references. The end.
That was amazing. That was amazing. Thank you, Jessica. All right, so we're going to hear from a few more of our sponsors who are making this possible. Most of them are running raffles, and you can win fabulous prizes, so make sure you go see them over lunch. But come on up. Please tell us about our sponsors.
Okay, so first up we have Mandy from VMware.
Hi. Do you have a clicker for me? Thank you. Ooh, it's bright up here. Hey everybody, I'm Mandy from VMware. I'm actually really excited to be at this conference. I've been at a lot of tech conferences during my career, and this is by far my favorite. And there's a few reasons for that. It's great content, as we just saw from the previous presenter. It's inclusive, it's considerate. There is a lot of consideration has been gone into this, and it's welcoming. And I think if I had had a community that was welcoming like this earlier in my career, where I could be today. So I think a lot of kudos goes to Bridget and team for putting this together, because it's not easy, and I think it's a great, great conference. So many of you may already be familiar with VMware, and some of you may not be, but we are a software development company and have been since inception. We've been solving hard technical problems through software since about 1988. So we understand your challenges. We understand them because we've lived them. We've gone through transitions internally ourselves. We're currently moving from a packaged solution provider to a SaaS solution provider, and we can help you guys through some of those transitions too with the experience that we've had. We've transitioned internally to a DevOps culture. We have teams that are willing to come out and talk to your teams about what we've experienced, what's worked and what hasn't, and to learn from you about how your own internal transitions are going. And we've also had to evolve and transition as a company ourselves, partly because it's in our DNA to do so. We were born as a company of disruption, and we continue to be one, but also because we have to survive in this rapidly changing market. We're active in the open source community, as you guys are. We invest in, we contribute to, and we rely on open source software. We try to take the risk out of it so that you guys can be innovative in your own environments without taking on some of that risk yourselves. And then we try and help you accelerate in your own agility and innovation by helping you accelerate your own journey to the cloud. So whether that might be our solutions that will help you move more quickly towards a hybrid solution, a multi-cloud solution, or cloud-native applications, we try and support you in all of those journeys. And we have a cloud management platform, both our existing platform and our next generation platform, that will let you manage all of those kinds of workloads, whether it be in your own premises, whether it be something that's moved to the cloud, something that was built for the cloud, something that's native in the cloud. We manage all of those kinds of solutions. And then we're already trusted in your environment. You may not know or particularly care that 80% of your workloads in your enterprises typically work on VMware, but you don't have to, because we take care of that. What that means is we understand your organizations already. We understand the scale required, we understand the complexity, the regulations and compliance, so that you don't have to, so that you can focus on being innovative and building functionality and services for your customers so that you can stay current. We also have 2 out of the 3 Kubernetes founders at VMware, which might be interesting to you. So with our Heptio acquisition from last year, 2 of the 3 founders that came out of Google after building Kubernetes actually now work at VMware. So we have some experience there that we didn't have previously, and we are happy to share that journey to you and with you. So we're at booth 29 in the Solutions Exchange. We would love you to stop by. We want to hear about the innovative things that you're doing in your own environments, and we want to share with you some of the things that we're doing in our environments. We want to share our solutions with you and how they can help you. Actually, on my way here this morning, I had to steal a monitor from my son's Xbox, and he's been texting me every 15 minutes to say, when am I getting my monitor back so that I can play Fortnite? So I want to make the best use of it possible. So please stop by so that I can tell him that it went to a good cause today. Thank you.
Thank you, Mandy. All right, next we have influx data. Come on up, Chris.
Howdy. I'm a developer at Influx Data. My name is Chris, and I have the privilege of working on a team that is building a database that is about modeling time and the kinds of things that change over time. As an architect, I get to have unique challenges around the kinds of daily data that comes through our DevOps process, everything from metrics to logs. And we've been spending quite a little bit of time building our newest cloud SaaS product, which is put out in our beta in about a month. And I really would love to talk to you all about what kinds of architectures that you're interested in and how you yourselves are modeling data that changes over time. Something that's near and dear to my heart, and I think I really enjoy change, and I think that we all want to enjoy that DevOps process and try to make things better and better. So, can't wait to talk to y'all.
Okay, next up we have Bob from Pivotal.
Thank you, hello. Agile, DevOps, cloud, multi-cloud, hybrid, paired programming, pizzas, supercalifragilisticexpialidocious. Did you get it? Yes. Good. All right, Pivotal, we're changing the way the world develops software. We are the tip of the spear for VMware. We help enterprise companies get out of that monolithic era and into the cloud-native microservices, secure way of developing and releasing software for their customers. We're working with Fortune 500, Global 2000 companies all over the world. Come talk to us at our booth. I have socks, SOCKS. That's what it is.
All right, next. Oh. All right, PagerDuty.
Hi, we are here from PagerDuty and incredibly excited to sponsor such a great conference with amazing attendees and organizers. Thank you for all the hard work you've done. Real quick, who here has been on call at some point in their life or currently is on call by a show of hands? Wow, all right. So what we would love is for you to come by our booth and tell us your on-call horror stories. We want to hear it. And while you're at it, you can enter in to win this amazing This Is Fine puppy dog by either tweeting or filling out our non-spam form. So we'd love to see you, and thanks for being here today.
All right, and last but not least, we have Nutanix.
All right, hello, welcome. What is Nutanix? We're an infrastructure, storage as a service kind of company that in essence can help you. For the people who don't like dealing with maybe the AWSs or the GCPs, you want to have something on-prem. We're in essence a storage server platform company that can provide NFS, CIFS, objects, VM storage, whatever it might be on-prem, fully all API capable so that you guys can sit and call and do whatever kind of work you want on-prem, scale up. It also has connections into all the clouds so you can replicate and move your applications and workloads over to the clouds or back on-prem. So come stop by, have a chat with us, and we can hopefully help fix some of your solutions.
All right, thanks again to all our sponsors.
Thank you so much, Karen. Okay, so we have one final talk this morning, and I'm so excited. We're going to hear from Nivea Henry. Nivea, come on up. I don't know about you, but sometimes I get a little worried about the world we're building, and I kind of hope we're not building a terrifying or terrible world. And I think Nivea has a lot of insights, ideas, and information for us about exactly how this world of ours should go. Give it up for Nivea Henry.
Hello. So, as Bridget mentioned, I also have the honor of being the last speaker before lunch. I take this responsibility very seriously. So I will not only keep you awake and energized, but I will shut the hell up so you can get out of here on time. Cool, let's hit it. Let's hit it. Let's hit it. Here we are. Hi, y'all. My name is Nivea. I've been in tech for a very long time, have held many roles, I find that curiosity is the one consistent skill that has gotten me through tech and somewhat successful. Currently, I currently ply my trade as head of an engineering group at Spotify. Please buy our stuff. And I'm here to talk to y'all about something that's very important to me, not because I'm a data scientist or an ML engineer, but because, like many of you, I am a human. And as Bridget mentioned, it's very important to me that we utilize the agency that we have as technologists. And one area that I see as at risk to doing that is machine learning and automation. So that's what I want to talk to you all about. So specifically, we'll discuss the differences between what AI means, what artificial intelligence, machine learning, what are the possible harms they might have caused, though I think Jessica did a wonderful job of teeing that up, and the way to mitigate some of those harms. Cool. So let's get past some of the word salad just so that we have common language. So many people think that basically the relationship between AI, ML, and deep learning is sort of a nesting doll model. And that's not really the case. Really, it's more like overlapping entities, whereby artificial intelligence really means human intelligence that are exhibited by machines. So we would think of something like TARS, which is from my favorite movie, Interstellar. But really, that's not where we are. Where we actually are today are clumsy but helpful, trying to be helpful robots that don't even get, like, putting things on shelves right. So, like, if we're worried about the machines taking over, yeah, we have a little bit of time to figure that out. So, machine learning is different. Machine learning is basically algorithms that learn using data. And the more data you provide, the more input you provide, the better. And sometimes, by providing data and trusting that the algorithms make the right associations, we get interesting examples like ordering diapers and also getting recommendations for Call of Duty 4. No judgment. So one thing about machine learning is that it's not a single thing, it's a spectrum. And it ranges from unsupervised learning to supervised learning at the ends of the spectrum, and then reinforcement learning somewhere in the middle. Unsupervised learning just means that there's more hands-on teaching of the model. So you provide not only inputs, but you also provide correct examples, and then you teach the model what are the correct and incorrect inputs, and then the outputs are things like labels and clear associations. On the other side, where unsupervised learning, it's more like you provide inputs still, but you have less control of the associations that they make, and the outcomes therefore are more complex, but also less predictable. And then reinforcement learning is something somewhere along the middle of that spectrum, as I mentioned before. So lastly, deep learning is sort of like a concentration of machine learning where it's cascading layers of processing where each input is used in the next layer to process to make the processing. So the best example is the convolutional neural network that a lot of self-driving technology uses. Some of them use over 250,000 inputs just to then tell the car to steer left or whatever else it will tell the car to do. And oftentimes people misassociate the word, so I want to clarify that what I'll focus on today, and most of what we interact with nowadays, is machine learning, and sometimes, in rare cases, deep learning, as I mentioned with the car example. But here's a dirty, maybe not so secret, is really, we're like, yeah, it works, great. I have no idea why it works. And that's because, again, there's a ton of complexity associated with machine learning and deep learning. And again, that information, especially when we move to the spectrum of unsupervised learning, we lose a lot of, again, the transparency that makes us understand how the machine, the model, ultimately arrives at its decision. And so, again, Jessica touched on this, but again, losing transparency and trusting the machine, the risk becomes we have no idea. It's harder to predict what is ultimately going to happen and whether or not the data is what we intended to, or the outcomes are what we intended from the machine, from the model. So why that's important is there's this concept by James Mickens, I hope I'm doing his name justice, but he talks about a concept of technological manifest destiny, which is the idea that we assume these three paradigms. We assume that technology is value neutral, and therefore more technology means more good outcomes. As exampled by Twitter and 8chan, hopefully y'all know that ain't true. We also think that, well, if all technology is good, let's get it out there as fast as possible. Who cares about understanding it? Let's just get it out there and see what it does. And then we're like, history, what's that? We don't actually recall and remember histories of where we had massive failures as a result of technologies that we've gotten too fast without understanding the impact. So with these paradigms, we're like, oh, we don't understand machine learning. That's great. Let's get it out there and see what happens. And here's what happens. So what happens ultimately is this concept called algorithmic bias. And there's a fancy internet definition, but basically it's when machines and models sort of adopt the decision errors that they learn from the data provided to them. And these have effects, these have real world effects. Some of them are funny because they're just harmless error. Maybe autocorrect or autocomplete is a hilarious error that we might find, but then there might be bigger injustices like damaging one's brand, Google, injustice that could happen, or even physical harm, as we'll see in cases of driverless cars and possible military usage of ML. So I meant to have a trigger warning. So I am going to share with you some examples today that are triggering, they are disturbing, and I share them because I want to jolt us out of thinking that, oh, these are just models. We'll just TensorFlow it up and we'll sprinkle some machine learning on it and nothing will happen. And I want to show you examples of that not being true and the effects they have of it. So forgive me in advance. So I'll give you the first example that completely applies to me because look at my hair, right? This happened about a year ago, I believe, where when one Googled professional or unprofessional hairstyles, the results were very different. And I wonder if y'all could spot the trend here on the professional versus unprofessional. Yeah, and this is again a result of this is a result of machine learning because Google is a heavy user of models and algorithms in predicting and returning search results. And of course, the data collection and some other factors can get it very wrong. Here's another example. This is on a camera, and this is deeply offensive. I saw somebody just wince, and you're freaking right. I mean, that's awful. And again, this is another result of trusting our automation to get it right 100% of the time and not understanding our actual users and maybe not having the appropriate amount of representation to be able to catch these types of errors. Back to Jessica's earlier point, humans matter, y'all. And this one is especially disturbing. So this was a proprietary model developed for the Department of Justice that's been used pretty regularly in determining what to set bail at. And it turned out that model, even when compensating for factors like risk of reoffending and level of severity of the crime, on average, or repeatedly, they rated people of African American or people of color a higher risk factor. And again, you can almost walk back to the data collection to see where the errors were made and how the model learned the wrong thing, and without having guardrails and humans there to interpret the data and to assess the actual validity of the outcomes, we see these kind of results that can literally result in an injustice for a particular group. And I have one more. This one's just funny, but the topic is very serious, and it's about deepfakes. Raise your hand if you've heard of deepfakes. Everyone has, so I'll just play the video.
Show me how.
The sound doesn't really matter that much, so it's okay if you can't hear it. But yeah, like, isn't it cool that Tom Cruise visited somebody's office? No, actually, Tom Cruise didn't. This is a deep fake. And the idea here is that deep fakes allow us to use machine learning and deep learning software to be able to overlay and faces of anyone that we want to on someone else. We can change their language, we can change the words they've said. And as we're already having a problem with information and trust and transparency in our systems, especially our political systems. Deepfakes has the risk of completely derailing our ability to discern accurate information, which will have downstream effects and impact on our political system and ultimately our lives. So you might be thinking, well, this is horrible, the people are horrible. And I would say, no, that's not true. Don't attribute to malice. This is not about malice. This is not about harmful intent. This is much more about lack of awareness and maybe a little bit of the manifestation of that technological manifest destiny that I talked about before. And so our jobs here isn't to say, well, just ban AI, just ban ML, because that's unrealistic as well. What we have to do is become more aware and also not lose the importance of having humans participate in these systems. So let's talk about, okay, well, what does that actually mean practically? In other words, how do we bust them ghosts? I actually just wanted to use this picture because I think it's so freaking cool. I don't care if I was talking about, I don't know, any other topic, I would have still used this and found a way to weave it in. Anyway, so first thing we have to do is clearly define the problem. I'm going to show you an example that's, again, triggering. And it's going to be an example of when you don't define the problem or you keep the problem scope too broad, and here's what the effects might be. How many of y'all remember Tay tweets? Good old Tay tweets. Did y'all know that it took Tay less than 24 hours to go from like innocent humanity-loving bot into like a complete Twitter asshole? Like, we turned Twitter Tay into like the worst thing possible in under 24 hours. I'm proud of us. Good job. And that happened primarily because we didn't understand the scope, or we didn't properly scope. So we took an original problem of how do we increase social connections, and how do we ensure that, or at least encourage others to participate in conversations by having some kind of innocuous Twitter bot that helps you generate conversation. And we're like, oh, this is a good idea. Now throw it to Twitter and see what happens. And this is what happens. So the ways to mitigate that are, first and foremost, consider whether or not your solution really needs to be an algorithm. Rules-based heuristics are simple, predictable, transparent, and oftentimes, I would say 80% of the time, more than capable of addressing your needs. Just because a technology exists doesn't mean we have to use it. When we are going to use it, though, try to define the objective and problem as narrowly and clearly as possible. Y'all are probably familiar with user stories. I would say put that concept and that thinking into high gear when you're applying machine learning by being super specific on the scope. Remember, these models are trained to learn through inputs. And sometimes if we derail or provide irrelevant inputs into these models, they'll learn the wrong things and they'll manifest in very strange and unpredictable ways. That's why we should also be very clear about the success criteria, what's acceptable, what's not acceptable. Maybe someone should have programmed Tay not to be racist, just thinking. And keep very clear scope and watch out for scope creep through your training data as you validate your model and put it out in the wild. So speaking of data, that's another aspect that's critical for machine learning. So just real quick, basically, there's usually multiple sets, when you're training a model after you actually design the model, there's multiple sets of training data that you use, not only to exercise it, but to also test and validate that it's accurate. And you have to keep those pieces of data very partitioned from each other so that they don't sort of corrupt one another. So here's another example of where the data really corrupted the experience in the model and the output was averse. In the United States, there was a facial recognition software that was being tested that would have eventually been used by a lot of major companies, including IBM. And it turns out that it easily identifies white men, but not black women. I can get that. And again, what happened here is they had a ton of data that, a ton of examples of white males and not enough examples of black women. Just to give you a counterexample of why this is not necessarily intentional, in Australia and New Zealand, the opposite happened. It was much harder to identify, I'm sorry, not Australia and New Zealand, it was in Asia, and I believe it was actually Japan. It was much harder to identify white men than it was to identify a different ethnicity group, again, for the same reason. There was an overpopulation of one source, one set of data versus the other, so the model just got better at identifying the data that it was trained on the best. So ways to mitigate that, again, be super explicit about your data collection strategy. Understand what kind of data is necessary. Understand whether or not that data is varied enough to train and test against. And conduct an exploratory data analysis, which just means try to find and visualize ways of how the data is associated with one another. And there's many tools and techniques to do that, but the result is the same, which is sometimes when you lay out your data sets and you compare and contrast them in visual ways, you can see patterns that emerge that you might not have otherwise seen by just having sort of like a list of data sources. Whenever possible, use open source data sets into your models because, again, it just injects diversity in a way that your own data sets might not be able to. And then, of course, use crowdsourcing to fill gaps. This is assuming that you're all going to walk out of here at lunchtime, develop your own machine learning model, which I totally know you will. Next thing, representation matters. And Twitter's a freaking firestorm, but oftentimes I hear arguments about is it really that important for for there to be actual diversity and representation in tech? Because at the end of the day, what we really care about is building the best product and so on and so on and so forth. All that's garbage. And here's another reason why. First of all, it's important to know that machine learning engineer is one of the fastest growing types of engineering in technology today, but remember, over 60% of technologists and possibly the people who will assume these machine engineering roles are white males. And so what happens is we'll have very small representation of women, which again sort of misrepresents our data set, and of course of people of color, which is why we saw some of these things before. And the outcomes, again, are real, right? So here, Jarrett Hill posted that there was a machine, an airport body scanner that went nuts because of African-American hair. And again, this is the critical reason why I say representation matter. It's not a philosophical conversation, y'all. It's about having the people in the room who look like the people who will use your stuff, because they will call things out that there's no way a program or an algorithm will find. If there was somebody with my hair in that scanner, we would have been like, hold up, this don't work, right? We would have been able to identify that in 0.3 seconds, no tech needed. So another factor in machine learning models is making sure that, again, you institute guardrails and checklists. And what I mean by that are things like scoring your algorithms for bias explicitly, or having explicit conversations through ethics and working groups to ensure that, again, you're having these types of conversations actively and identifying bias from humans. Another really important one is conducting post-market surveillance, which is an idea that borrowed from pharmaceutical development, pharmaceutical product development, whereby even after the either device or medication is out there, they conduct continuous analysis and surveillance to ensure that, again, it's working as the sample group predicted and as expected. So here's some examples. I won't harp on them, but the idea here is that there are ready-made tools that we can use in order to do these types of ethical scans, and so use them. Find out what they are, talk to me afterwards, use them. And lastly, you have agency. Like, all of us here are technologists, and all of us here are humans for the most part. And so what we have to do, I know there's some robots hiding in the crowd here. What we have to do is we have to be super mindful about the things we contribute to. You know, we have the power to say, yo, this is going to cause harm. Can we back up and talk about this? And some of us might even have the agency to say, I'm not signing off on this going to production because I don't feel that we've had these conversations about what the impact will be. And it will have, like, it won't go unnoticed. Recently, last year, Amazon workers demanded that Jeff Bezos cancel the face recognition contracts with law enforcement. And that got 126,000 flames, which is important in social media. But the point is, it generated conversation. And same thing, a group of scientists signed on to a manifesto asking that weapons do not use AI technology because it'll malfunction in awful ways and innocent people will be killed. Sadly, they were ignored. But the point is, they were using their agency just like we all can use ours as technologists. So, in summary, ghosts aren't real. Sorry, whatever TV shows exist on TLC. Algorithmic bias is, though. And it's up to us to mitigate and eliminate those harmful effects, because technology is neither good, it's neither bad, but it's also not neutral. All right, well, with that, my husband and cat, Andre and Lyra, thank you for your time today. And we have 6 minutes left for y'all to go get lunch. I finished on time. I aced this test. Yes!
All right, thank you so much, Nivea. Let's not exit through the door there. If we exit through the doors here, we can make lunch happen as effectively as possible. And please follow the directions of the people who are guiding you through lunch. We have about the same number of people as last year, and I think lunch took under 10 minutes to get everyone food. Feel free to sit in any of the places that you see chairs and tables. It would be better if you do it out there rather than in here. And if you choose to sit in the quiet room, please do keep it quiet, since people will be in there if they need quiet. We will see you back after lunch. We will see you back at 1:15. You can see the schedule right there. And so you have a little over an hour to have some lunch, visit the sponsors, And we'll see you back here at 1:15. Bring all your ideas that we sparked this morning. Thanks.